Have you heard about orthogonal circles before? Would you like to know what that means? Okay, so we are going to consider the concept of orthogonal circles. Before now, you should have heard about orthogonal lines, orthogonal vectors and all of that. Orthogonality in the sense of it refers to perpendicularity. All right, so how can circles be orthogonal? And here we have a question. It says two circles C1 and C2 with radii 8 cm and 6 cm respectively intersect at points P and Q if C1 and C2 are orthogonal. All right, so you can immediately see that concept here. Find the distance between their centers. Okay, so what are we expected to do? Now you've got to know what an orthogonal or what it means for two circles to be orthogonal. Now, first of all, here we have two circles S1 and S2, okay, and they are meeting at a point. So let us call this meeting point P and Q. Okay, all right, so there are about 2 to 3 concepts I'm going to define on these circles intersecting at this point. Meanwhile, notice that this line here, straight line here called L1 is a tangent on S1, while line L2 is a tangent on S2 at point P. Okay, while this other one is, I can call this L3, so this is a tangent on S1 at Q. If I call this one L4, is a tangent on S2 at Q. All right, so what are the 3 concepts or 2 that I said I'm going to explain? Okay, the first concept is what we call angle between circles. Okay, so before now we talk about angles between lines. Now circles can also form angles. How? When they intersect. So how do you get to know the angles between two intersecting circles? All you need to do is to draw tangents on their point of intersection. So here you can see there's a point of intersection, all right, and you have tangents. So the angle between the tangents, the two tangents formed on the two circles at that point is called the angle between the circles. So this is defined as the angle between the circles. Now, the other thing you need to note is that since these two circles are intersecting at 2 points, so that means we can actually have the angles formed at 2 different points. Okay, so assume that this is theta and this is alpha. Now, the second thing that you need to note here is that the angle theta geometrically is always equal to angle alpha. So the angle that two circles intersecting at 2 points will form, that means if you're able to get these two tangents here and then here also, the angle that will be between the two tangents on top here will be equal to the one that will be down here. So that is the second point that you need to know, and that would eventually drive us to now define this concept. So, and what is that? Two circles intersecting at 2 points or at any point is said to be orthogonal if the angle between them is 90 degrees. So if our theta is 90 degrees, then you can say that the two circles are orthogonal. So when theta is 90 degrees, then S1 is orthogonal to S2. Orthogonality, remember I told you it means perpendicularity. All right, and so that is just it. But then that is not all that you need to know when it comes to orthogonal circles. And what's that other point, which I'm not going to be writing, but then you can write it down. The other point is that when two circles are orthogonal, the tangent to S1 will definitely come to the center of the tangent, the center of S2, while the tangent to S2 will come to the center of the circle S1. Remember that this is a freehand sketch, but if it is geometrically done using maybe a protractor and a compass and all of that, you will definitely get this concept perfect. Once you're able to get a tangent and then the other tangent is perpendicular, that means they are orthogonal. The other tangent will come to the center of the second circle, while the tangent to the second circle. All right, so you're welcome. Do you want to know the transformation that just happened? Okay, I would invite you to come over to Nigeria. All right, so back to where we are. All right, so we're supposed to find the distance between the centers of these two circles. The last part which I noted is that the line, this particular tangent of circle 1 meets the center of circle 2, and the tangent to circle 2 gets to the center of circle 1. All right, so let's assume that this is the center of circle 1, which is A. So that means this tangent gets to the center, and let's take here to be the center of circle 2. So that means the tangent of circle 1 gets to it. Let's call it A. So the implication is that by the time you join the 2 points, which is actually the distance we are looking for, so you are going to get a straight line, which is going to be the hypotenuse of a right angle triangle that will be formed here. Okay, so all you need to do now is to get the value of that hypotenuse, and then from the diagram we are told, from the question, we are told that the radius of the bigger circle C1, I've actually changed this to C1 and then C2, so is 8 centimeter, while the radius of the other circle is your 6 centimeter. Okay, so now solution to this problem is going to be that by Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the other two sides, so which is going to be 8 squared plus 6 squared. Then of course, if you now take the square to the other side, it will mean that our AB is going to be equal to the square root of 8 squared is 64 plus 36, that is 100. So you have the square root of 100, and the square root of 100 is equal to 10, and which is 10 centimeter. So what it means is that the length or distance between the two centers, or the centers of the two circles that are orthogonal at these 2 points, is equal to 10 centimeters. That is what I said to show us in this video, and if the lesson made sense to you, please give a thumbs up to the video, and then also share it, subscribe to this channel. We'll see you in our other videos. Bye.